What is going on, everybody? Back at it with another example video on linear transformations. Let's go! uh, we are gonna, like I said, continue with linear transformations because there's a lot of examples that we can do. We've talked about images and pre-images and checking if a function is a linear transformation. So now we're gonna do a little something that is a little bit harder, but honestly, it's kind of fun if you look at it in a different perspective. And so it will pretty much be finding the image, but you are not given the function. So so you're probably asking, like, how do you find an image of something that doesn't tell you what to do? Well, it doesn't give you the function or the instructions on what to do, but it does give you a set of images or a set of pre-images and images, and from there we just kind of have to figure out like how we're gonna do it. So it's like a little puzzle. You are given in this example, you're given um three inputs and three outputs, and they tell us to find some fourth output using what we're given. So let's get right into it. This is a little bit easy, um, and you're about to see why. And then in our next video is going to be a little bit much more harder, and there is, I guess, two methods to do it. There's a long way and there's a short way, but you have to pay attention to like the question itself. So enough of that, and let's actually get into it. So we're gonna let the function t go from R3 to R3 and have it be a linear transformation such that t of 1, 0, 0 is equal to 2, 4, negative 1, t of 0, 1, 0 is equal to 1, 3, negative 2, and t of 0, 0, 1 is equal to 0, negative 2, 2. And so we are told to find t of 0, 3, negative 1, t of 2, negative 4, 1, t of 2, 1, negative 0, and then t of negative 2, 4, negative 1. So how are we going to do this? Well, there's some keywords that you have to understand. The first one being that this function is a linear transformation. So if you recall that a linear transformation means that it is closed under addition and scalar multiplication. So what that means is that t of a plus b is equal to t of a plus t of b. We've done these in the last video and we have to show that this is true. And then k of ta is equal to tka. And we can use these in our advantage. And we're going to use these two properties that are closed under addition and scalar multiplication, because it's a linear transformation, to find what they're telling us to find. So to find t0, 3, negative 1, well, we can use the fact that this is closed under scalar multiplication. So what we can do is this will just be equal to 3 multiplied by t 0 1 0 minus, let's do instead of minus 1 times t 0 0 1. Because we know that this is a linear transformation, we're going to use the closed under scalar multiplication. So this would mean that this is equal to t of 0, 3, 0 plus t of 0, 0, negative 1. And then again, now that we showed, now that this is closed under scalar multiplication, we can also use the fact that this is also closed under addition. So this will just be t of 0, 3, negative 1. So all we have to do is just substitute these, substitute what these are, which we know because they were given, the 0, 1, 0, and then the 0, 0, 1, and then just multiply by the scalar products. So this would essentially be 3 times the 0, 0, 1 would be 1, 3, negative 2 minus 1 times 0, negative 2, 2. So this would be distribute 3, 9 minus 6. I think I'm doing this right. Plus 0, 2, negative 2. And then you add them together. So we have 3 plus 0 is 3. 9 plus 2 is 11. And then negative 6 minus 2 is negative 8. And that is our answer. So that one was easy. Now the next one is the same thing. We use the fact that all of these are linear transformation, so it's closed under addition, scalar multiplication, so we can pretty much skip this second step, I guess these second and third step, and then just plug in the scalars. So this, on example 2, t of 2, negative 4, 1 is the same as 2 times t 1, 0, 0 minus 4t of 0, 1, 0 plus t of 0, 0, 1. Substitute in our function, so we have 2 times 2, 4, negative 1 minus 4 times, what's the other one? 1, 3, negative 2 plus 0, negative 2, 2. Then again, distribute. So we have 4, 8, negative 2 plus negative 4. Negative 4 times 3 is negative 12, 8, and 8. Plus, nothing happens here. Now we add. So we got 4 minus 4 is 0, plus 0 is 0. 8 minus 12 is negative 4 minus 2. It is negative 6. And then negative 2 minus, no, 8 minus 2 is 6, plus 2 is 8. And that would be our answer to the second function or transformation. The third one, okay, cool, I have them written. Okay, so I don't have to go back up. So the third one, this would be, again, 2 times t of 1, 0, 0. Now this would be t of 0, 1, 0. And then since 0 is on the other one, it's just plus 0. So that wouldn't really matter much. So now again, we're going to substitute back, or substitute what our function yield. So it'll be 2, 4, negative 1. And then minus 1, 3, negative 2. Distribute 4, 8, negative 2. Plus negative 1, negative 3, 2. And then this would be 4 minus 1 is 3. 8 minus 3 is 5. And then 2 minus 2 is 0. So that is our third one. And then finally, our last one. Again, we know what our constants are. So this would be negative 2 t of 1, 0, 0 plus 4 of, not t of 0, 1, 0 minus t of 0, 0, 1. Substituting it back in, we have substituting what our function yields is 2, 4, negative 1 plus 4 times 1, 3, negative 2 minus 0, negative 2, 2. So this would be negative 4, negative 8, 2 plus 4, 12, negative 8 plus 0, 2, negative 2. You add them all together and you get 4 minus 4 is 0 plus 0. 12 minus 8 is 4 plus 2 is 6. And 8 plus 2 is 10 with the negative, negative 10 plus 2 is negative 8. And that is our final answer. So this example was fairly easy. The reason being is because the functions that they gave us, or I guess the inputs, which is the pre-images, are, you could say, the the most simple ones. The 1, 0, 0, the 0, 1, 0, and then the 0, 0, 1, which if you put them in a matrix, use a different color. If you put them in a matrix, it'll be 1, 0, 0, 0, 1, 0, and then 0, 0, 1. So it's kind of like the identity, if you want to see it like that. So this was one of the easiest ways to do it. In our next video, it's going to be a little bit much harder, so it requires a little bit more work, but it's not something that is completely new. It is something that you've done before, and you just have to wait and see on what we do. But until then, hopefully you guys learn something. Hopefully this makes sense to you. In cases like these, all you really have to do is just plug in your k's, which you know because it's literally, that is not a highlighter. It is literally what the function gives you, because they're all 1, 0, 0s, or 1s and 0s, so it'll be fairly easy. But yeah, I'll see you guys in the next video.